Young salmon are some of over 100 million that each year start their journey down the Columbia River and out thousands of miles into the Pacific. But scientists say that America's salmon are at risk of becoming extinct. On this edition of Scientific American Frontiers, we're looking at the future of the ocean's long-distance travelers. In the Northeast, can biologists figure out what makes Atlantic salmon tick before the last few rivers lose their wild fish? In the Pacific Northwest, will elaborate engineering save the Columbia River's salmon? And in the Atlantic Ocean, scientists are beginning to understand the giant bluefin tuna. But will the rest of us put that knowledge to good use? I'm Alan Alda. Join me now as we plunge into a deep crisis.
This program was made possible by contributions to your PBS station from viewers like you. Thank you.
Inside this building, there's a small food processing company. There must be thousands like it around the country. Nothing special about that, right? Well, in fact, what goes on in here is really special. And when you think about it, really surprising. Because what they do is prepare meat from wild animals for shipping to the shops and markets where we'll all buy it. Let's take a look. That's right, fish. Fish are wild animals, with some exceptions, which we'll get to in a minute. 10,000 years after humans domesticated cattle and sheep and pigs and figured out how to cultivate crops, we're still out there hunting down wild fish to put on the table. Today, seafood is the main source of animal protein for about 1 billion people around the world, and its importance is growing rapidly. Fish consumption has gone up fivefold since 1950, and it's still going up. The results are not hard to imagine. Marine fish stocks are being overfished, and they're declining fast. What to do about damaged fisheries is a terrifically complicated question. It involves many interests: industry, fishermen, environmentalists, local economies and livelihoods, even foreign policy. But this program is going to concentrate on what all those interests need to know before they start to argue: the science. We have to know how fish behave, where they feed, where they breed, before we can begin to figure out how best to conserve them. We're going to concentrate on two kinds of fish that we in America love to eat: salmon and tuna. Even though salmon farming is big business, wild Atlantic salmon are now officially endangered in the U.S. And even though millions of young Pacific salmon are raised in hatcheries in the Pacific Northwest, several species of wild Pacific salmon are officially endangered too. We'll look at the work of biologists on both coasts who are now trying to determine how wild salmon can have a future. And we'll look at the efforts to study the giant bluefin tuna, another long-distance ocean traveler. Studying bluefin is especially challenging because an individual fish may range over enormous distances, across the entire Atlantic, for example. Scientists are just beginning to find out about the ocean wanderings of the giant bluefin. Even something as basic as counting fish in the wild hasn't been attempted until recently. And guess what? Everything we discover comes as a surprise. Okay, let's dive into a fish's world. When Lewis and Clark explored the West 200 years ago, they saw sights like this. On the Columbia River, the salmon were jumping very thick, wrote John Ordway, the expedition's senior sergeant. So what are all these slots in here? Today, the Columbia is just one part of a settled and industrialized Pacific Northwest. It's not impossible to see a wild salmon jumping a waterfall, just a lot harder. Dams are the most visible of many reasons for the decline of the Northwest salmon. Here on the Washington-Oregon border, the Army Corps of Engineers McNary Dam, opened in 1953, reaches for a mile across the river. It's one of hundreds of large dams distributed throughout the enormous Columbia Snake River system, which stretches across 4 states and up into Canada. Several of those dams completely blocked fish from going upstream, knocking out more than a third of the system's salmon habitat. The dams made life for the remaining salmon much harder. When young fish head out to the ocean, for example, they have to contend with this. McNary's electric generating turbines can kill young fish, but about 15 years ago, the way the dam was run began to change. Is it that the environmental protection laws have required you to run the plant in the way that's best for the fish?
Oh, yes.
And so it's not just running the plant. You have to worry about the fish as part of your job now.
Guaranteed. I mean, when I first hired on the Corps, the most important thing at this facility was the safety of the employees, navigation lock, and power. Since I've been here, safety is number one, fish is number two.
You can see the result in the control room. The 14 turbines could together produce 980 megawatts, but today they're running at less than 860. This is a salmon smolt, a one-year-old fish that's ready to move downriver to the ocean. It's about to experience McNary's turbines firsthand and then report back. First, there's a mild anesthetic, so a radio transmitter and flotation balloons can be attached. This is one of millions of smolts raised in hatcheries each year. At the last instant, a foam mixture is added to the balloons, and then... Now he goes down through the turbine, huh?
Yes, he's going right through the turbine.
Down it goes, 70 feet deep through the spinning turbine blades, then out below the powerhouse. By now, the flotation balloons will have inflated, so the fish will be somewhere downstream on the surface. Meanwhile, the researchers are sending down a somewhat less lively instrument package. In the river below the dam, the recovery crew is on the lookout. Within minutes, they pick up the radio signals from the fish and the instrument package.
O'clock.
Surprisingly enough, the smolt made it through unharmed. In fact, around 90% survive if the turbines are run at flow rates which reduce forces on the fish, as they are today. Those forces can be measured with the instrument package while turbine speeds are adjusted. Now, all the Army Corps' Columbia turbines are run to minimize fish losses. On a typical Columbia dam, half the structure is the powerhouse. The rest is spillway. As with the turbines, spillways are also now operated with fish in mind. That's a great sound. It sounds like Niagara Falls.
It kind of is like that. Our spillway. Today we're spilling about 100 kcfs.
That's a spectacular sight. The ability to do a spill like this on the dam, was that intended originally as a kind of a pressure valve when there were flood conditions?
Correct.
There wasn't with the fish in mind at all.
No way.
Now you open the spill for the fish as well as for the flood.
And it's an interesting story because originally, when you had a spring runoff like this, that's forced spill, it used to cause a lot of harm for fish because the water used to plunge straight down, super saturate the water, nitrogen. They'd get like the bends, and it'd cause a lot of mortality. So all the dams have been retrofit with what they call flip lips, and actually slides the water kind of out instead of plunging it down.
With flip lips, and if the flow rates are just right, approaching 100% of young salmon can make it through a spillway. So it doesn't sound too hard for a young fish to get past McNary Dam. But that's a small part of the challenges facing the Pacific Northwest salmon. Let's take a look at the Columbia system from a salmon's point of view. In we come from the Pacific Ocean through the estuary. We've been using our internal compass to get here. But now, as we head upstream, we're beginning to pick up the distinctive smell that we remember from the water where we hatched 4 or 5 years ago. We're determined to spawn in the exact same river, lake, or stream. and were prepared to travel 500 miles inland, 1,000 or so river miles to get here. Now we've arrived in central Idaho or eastern Oregon. Once there were hundreds of different groups of us salmon in the Columbia system, distinct stocks that each used the system in its own unique way. We find the stream, find the right kind of gravel, find a mate, and make a nest for the eggs. Next spring, the fry hatch, then hang out and grow for a year before hitching a ride as smolts on the following spring runoff. Down the river we go, out to sea for a couple of years to eat and grow. Today, more than half the Columbia's original stocks are extinct. For thousands of years, Native Americans were the only people who exploited the Columbia salmon. But that couldn't make a dent in the 10 to 15 million fish that returned each year. Then, as the numbers of settlers grew in the 19th century, salmon came under increasing pressure. Large-scale net fisheries were established in the Columbia estuary. Canneries were set up. By the 1930s, returning fish numbers were down by half. At the same time, another bonanza was underway in the forests through which many salmon rivers and streams flowed.
Shoot them off the hillside, snake them down the creek, raft them down the river, out to the Pacific, to Africa and Australia and Ireland. Healer logs for the plywood mills of Japan, ties for the Trans-Siberian Railway, timbers for a North China mine.
Logging was devastating for the salmon. It turned clear, cool streams into muddy, warm pools that no longer support spawning. Some attempts are made to protect streams today, but it's still a serious problem. And then, on top of the fishing pressure and the logging,
At Bonneville, Oregon, man takes up the struggle against the frontier. Cascade Rapids, since pioneer days, the graveyard of ill-fated ships, in 1933 make way for Bonneville Dam. America's conquest of the Columbia has begun. Just as the Nile is the lifeblood of the historic land it drains, so this river of the West is the key to the future of the Oregon country. An unshackled giant becomes a seaway to an empire, the promise of power for every corner of the Northwest. Power to make 1.25 million acres bloom again. Power to push the city to the farthest county line. To bring better crops and better living to the farmers of the region. Power for the home. Good light for Billy's eyes. Electric cooking for Mother. The comfort of electric heat and electric coal. Leisure to replace the burdens of an outworn era. Power to make the American dream come true.
as far back as the 1870s, it was thought that we could have the American dream, and salmon too, by building these. It's a hatchery where young salmon are raised for a year until they're ready to go to sea as smolts. There are about 100 hatcheries in the Columbia system, producing about 200 million smolts a year. All hatchery smolts are marked by clipping a fin that's not used for swimming, an evolutionary leftover. This mark persists with the adult fish, so it's been possible to track how well hatchery fish do compared to their wild companions. Only about 10% of the smolts in the Columbia system are wild, spawned, hatched, and raised naturally without human intervention. But up to 30% of the adults that make it back from the ocean were wild smolts. Wild fish do much better in the ocean and the river. Biologists think they're more aggressive, know how to avoid predators, just smarter and tougher. Dams have made the river more difficult for all smolts, wild and hatchery. For example, there's not enough flow in the reservoirs behind the dams to carry young fish downstream, so they have to use precious energy to swim. Since the 1970s, a lot of effort and hundreds of millions of dollars have been put into helping smolts down the river. The most important dams have been fitted with elaborate screen systems to catch the smolts and divert them around the turbines and spillways. This is just one part of one of the 42 fish screens at McNairy Dam. The system works by directing the young fish up and away from the turbine intakes and into a separate channel inside the dam. The channel leads to a special fish processing facility. At the heart of the system are stainless steel screens that create a cushion of water to guide the fish. This is sophisticated and expensive engineering. McNairy screens alone cost $17 million.
The water is hitting that screen,
Correct.
and it's backing up a little bit.
Yes. So, and the fish are actually tumbling kind of back with their tail to the
Why
screen.
are the fish going backwards?
They're not really swimming to the ocean. They're just flowing with the current heading to the sea.
Is that how they ordinarily go down?
Yeah, the big spring runoff, just Mother Nature takes care of them and flushes them.
If you could have asked me a million times, I would never have said they go backwards to the ocean. That's
Okay, well,
what's happening here.
we're closing down shop. They got work to do. You're okay. If you don't move, you're okay. You're okay if you don't move. It's not an unusual amount of water, but it's...
Dave Coleman took me down inside the dam to see the channel where the separated fish end up.
We're entering the juvenile collection channel designed to pass...
We're here at the height of spring runoff, when they're collecting 350,000 smolts a day. The screens are not perfect. They catch 75% of some species, but only 30% of others.
Don't they get shaken up a lot? That's really going very fast, isn't it?
That's engineered by the greatest fish design engineers in the world, and that's perfectly acceptable.
The quarter-mile-long channel is just the beginning of a peculiar journey for the young fish. I saw my chance to check if they really were going backwards.
You can start to see some of the fish right here. There's one, there's one, there's one.
Oh yeah, now I can see them.
Dave was right, they do go backwards.
You know what it is? When you go someplace in the car, you can't find your way back because the scenery looks different in the other direction. They go backwards so they see what it looks like coming the other way, so they know where to go.
Actually, they head into the flow because that gives them maximum control. The diverted fish emerge from the dam in this pipe, which loops down into the fish facility. A sample is anesthetized so they can be identified and counted. The Columbia has 5 salmon species and 2 closely related steelhead. Hatchery and wild fish are counted. And now the smolt's journey is about to get more peculiar. For 15 years, about half the smolts in the Columbia system have been given a ride downstream courtesy of the Army Corps of Engineers. They're loaded into specially built barges, 250,000 fish at a time, and driven downriver in luxury, safe from turbines, spillways, predatory fish, and hungry birds. It takes a couple of days for smolts to get down below the Bonneville Dam, the last on the river. Almost all survive the barge trip, and a higher proportion of barged fish return as adults compared to those that came down the river on their own. But the return rate for both groups is very low, only 1% or 2, much less, it's believed, than made it back historically. There's a net system used to count smolts as they leave the river. One theory is that both groups are in poor shape as they go out to sea. The barged fish because they have to cope with salt water before they're ready, and the others because their river journey has been so stressful. Many smolts heading out to sea, still backwards, have electronic tags that the net system detects. They're called pit tags, microchips containing unique ID numbers. Once implanted, the tags stay with the fish for life. In the last decade, more than 5 million have been used on the Columbia, and they've revolutionized research. Pit tags have told us about the effects of barging. These fish are part of the continuing barging study. They've told us about the effects of turbines and spillways. They're a sophisticated tool to match the technology that, to the dismay of environmentalists, is now an integral part of the life of Columbia River salmon.
These are fish that have been collected up on the face of the dam and through a series of pipes.
I'm at the McNary Fish Facility with Mike Shiwi, the biologist who runs much of the research on the effects of technology on fish.
This is the juvenile fish separator, and this is where the different size juveniles are sorted.
The facility is a maze of pipes and channels equipped to detect pit tags and automatically divert a fish that's part of a study, for example.
If it were to detect a fish, now there's the, what would happen is, and then the fish just drops down below.
It's like an amusement park.
Oh,
ride.
it is, yeah, it's amazing. Let me do that again.
So when the fish goes through here,
Yes.
and the tag is read by the computer,
read
and
here.
that gate opens that fast. So by the time the fish gets there, the gate's open.
That's correct. It's an amazing system. It's what the computer age has brought to fisheries.
The computer age arrived on the Columbia just in time to help study a crisis. In the 60s and 70s, 4 new dams were built on the Snake River. Now, Snake River fish had twice as many dams to pass to reach the ocean. 4 salmon stocks began to collapse. They and 8 more stocks elsewhere in the system were declared endangered. For West Coast salmon today, the count is 26 endangered stocks, half of those that are left. The response at the 8 Snake and Columbia dams was the measures we've seen: fish screens, spilling water, and adjusting the turbines. Even so, about 10% of smolts are lost at each dam. Bypassing with barges helps make up some of the losses.
Does the fact that 10% die lead you to think that maybe the dams are stressing the fish, and that's why a lot of that 10% may be perishing?
Well, I don't think there's a question that the fish would survive at a higher rate without the dams. We've made major improvements, I think, in the system and how it operates in the last 20 years. Survival now for the yearling fish is roughly 50 to 60% through the whole system. The 8 dams coming down from the Snake River to the below the Bonneville Dam at the Pacific Ocean. This compares with what the survival was about 20 to 30 years ago when there were only 4 dams in place. But we hit a real low point in the 70s when more dams were coming online, when the operations were not as safe for fish. So we're making progress in that regard.
We're heading back to where we picked up the smolt that came through the turbine. It's a measure of how unnatural things are that there's a program to reduce the number of predators that hunt salmon smolts. Smolts make easy prey in the reservoirs where there's no shelter, and also as they emerge disoriented from the turbines and the spillways.
Be careful not to touch the water when the generator's on.
Okay.
It might give you a little buzz.
Don't touch the water while the generator's on. Liable to get electrocuted.
The electric shock stuns all the fish around the boat for a few seconds.
These are American shad. They're a game fish introduced from the East Coast.
We're going to pick out the 3 important smolt predators.
Those are all large-scale suckers. That's what we're looking for. You got a keeper. This is a walleye.
Now that's a predator?
That is a predator.
Back at the dock, the unfortunate walleye showed us where about 12 million smolts a year end up, 6% of the smolts in the system.
That is a fish that just popped out of his stomach.
Then Tom Friesen did a surprising thing.
Back in the water.
Now, if he's a predator, why do you release him? He's going to be able to get more salmon, right?
Right, walleye are a pretty highly regarded game fish, so if we just removed all we could, there'd be people upset that they couldn't fish for walleye anymore, and smallmouth bass are the same way.
So our smallmouth bass was also released. But not so the third fish. There's 1 million or more of them. They're not game fish, and fishermen are paid to catch them.
It's called the northern pike minnow.
It's hard to know how much effect this all has on how many adult salmon eventually make it back from the ocean. And that's the case with virtually everything we're doing on the river. This is the fish ladder at McNary, and right now it's full of returning adults. Last year was pretty good too, with 1 million returns. That's good news, but it's confusing. They got down to only 250,000 returns in the 1990s, just when all the efforts to help juvenile fish survive the downstream trip should have been paying off. So there are still big unknowns out at sea. Well, these are big guys, aren't they?
Oh, they're beautiful fish. These are summer Chinook. They've been down through the system as juveniles and been out to sea for 2, 3, 4 years, and now they're coming back.
You count every single fish that comes through.
Every fish that comes through the ladder comes by this window.
So this is where they come in?
Yes, it is.
And so you see one, what, you narrow it down so that you only get one at a time?
Exactly. Now that's a shad, big Chinook, another Chinook.
That ladder looked like a pretty long structure. Does that put them through more work than they would ordinarily have to go through to get up the river if there weren't a dam they had to climb up?
Well, before the dams, they definitely climbed falls, and so they went through those kinds of structures. Sometimes they have a little trouble finding the entrance to the fish ladder, but once they do, they move through it fairly quickly. Fish ladders are one of the real success stories of salmon migration.
As the observers do the count, they distinguish between wild and hatchery fish. Here's a wild Chinook with its rear fin intact. And here's a hatchery fish with the fin missing. Overall, about 2/3 of adults are from hatcheries. Hatchery fish saved the salmon fishing industry in the Northwest. But one concern is that hatchery and wild fish may interbreed. The remaining wild stocks could begin to lose their unique adaptations. Some wild stocks are now down to a few thousand returning adults. With some, only half of 1% of the smolts that went to sea make it back. So there may be 1 million salmon in the Columbia, but some may still be headed for extinction. It's vital, says Mike Shiwi, to preserve the variety of salmon stocks that we still have left. It's not just saving some salmon, it's trying to save as many kinds of salmon as you can. Otherwise, you're just leaving them open to the elements and they could get wiped out at any time. We couldn't predict when, huh?
No, that's exactly right. You're buying insurance against variations that are bound to occur. Populations of fish rise and fall over the years, and this diversity of different life forms, utilizing the habitats and the food resources in different ways, allow the salmon to persist at the levels that they do. So saving the diversity of salmon is every bit as important as just talking about numbers.
We're heading up the Narragansett River in down east Maine. For the biologists we're with, this rugged and beautiful country is in the grips of a catastrophe. This river, along with 7 others nearby, is losing its last few wild Atlantic salmon, and they don't know why. It's spring runoff, and the traps in the river have been set to sample the 2-year-old salmon smolts heading downstream to the Atlantic Ocean. Every year, the numbers go down. Just 2,000 this year, 1/10 of the numbers in the past.
One American eel.
The traps catch everything. The smolts they're looking for are wild, descended from wild parents that know only this river.
One salmon smolt. Okay, we got 2 smolts.
As in the Pacific Northwest, hatchery fish that are not adapted to a particular place are not counted as wild.
Dorsal score?
0.
The last wild Atlantic salmon in the U.S. are confined to 8 main rivers, and all 8 stocks are officially endangered. The numbers are incredibly low. In 2001, less than 150 wild adult fish returned to all 8 rivers combined. The numbers of smolts heading out are correspondingly low. For example, in the nearby Pleasant River.
Our crew here is, I think they're really feeling the numbers going down. It's not just looking at them on paper. Having been here last year, handled 60, 70 smolts a day. This year we haven't even broke 20 smolts a day.
Things got this way in the Northeast for the same reasons the Columbia salmon declined. Atlantic salmon were once abundant everywhere north of the Hudson River. But change came with colonization. There was large-scale fishing. Thousands of dams were built to power mills and factories. The Connecticut River, a major salmon habitat, was completely blocked. Logging, agriculture, and water pollution all took their toll. Throughout the Atlantic salmon's range, from Canada to Russia, the same processes were underway. It's now extinct in half the 50 or so major river systems it once inhabited. Healthy populations remain in parts of just 4 countries. The big concern is that numbers have continued to plummet even after heavy fishing in the salmon's ocean feeding grounds off Greenland was stopped 15 years ago. In Maine, research is going on to try to understand the causes.
Here you go, Tim.
They're going to implant an acoustic transmitter in a smolt and then follow it down the river and out into the Gulf of Maine. At the start of the research, they tested the effects of the implant, and surprisingly enough, neither the fish's behavior nor its health seemed to be affected.
The body cavity starts healing almost immediately post-surgery. Within a very short period of time, everything will be back to normal, and the fish will be on their way into the river and then out to sea.
Once the smolt is recovered from the anesthetic, it's released.
Okay, we got a good signal on them.
They follow the fish for a few hours to make sure it's healthy and the system's working.
The signal's really strong. The fish is quite close to us, probably within 40 or 50 feet, right up against the riverbank.
Right now, we know surprisingly little about the life of an Atlantic salmon smolt.
What we're hoping is, by understanding where the mortality may or may not be occurring, is there a single smoking gun? Are there a number of factors, each of which contributes a little bit? And in total, we're really sort of writing a missing chapter in the life history book. Let's go.
An array of 20 remote receivers is set out in the river and the ocean just offshore.
Things looking good.
They'll record the signal if the fish passes. So far, they've tracked 400 smolts, and only half have made it out to sea. That's as bad as the smolts that have to get through 8 Columbia River dams. And it's a surprise. But there is a pattern emerging.
It's a little suspicious that we're having more mortality than expected, and there seems to be occurring disproportionately in or about the area where they first hit salt water.
Research in Norway suggests that young salmon from acidified rivers have trouble regulating salt. So New England's notorious acid rain may be, if not the smoking gun, at least one of them. In the 1980s, the Pleasant River had a couple of dozen adult returns a year. It's just a few now. In some years, none. It's called an extinction vortex. Not enough breeding adults to stay ahead of the losses. As a last desperate measure, biologists are trapping and removing smolts to be raised in captivity. This is the strategy being tried with the California condor, for example.
Yep, smolt.
The young fish has the special adaptations that suit it to just this river. As in the Columbia, the only way to keep wild fish in the river is to preserve each unique stock.
There are differences between this river and the Narraguagus River right down the road. Differences in rearing habitat that we think over time have led to local adaptations. So it's important to put fish back into the river their parents came from.
Young fish from 6 of the 8 main rivers have now been removed for captive breeding. Genetic tests have confirmed that each river's fish are distinct. They're kept separately and they're only bred within their own group. This is exactly what salmon hatcheries in both the Northeast and Northwest have not done, which is one reason hatchery fish have low survival rates. Their genetic adaptations have been mixed up so they don't know how to use particular places. A puff of air helps this Machias River female release her eggs. She was brought here as a 6-inch long smolt 3 years ago, so now she's ready to breed. Her mate has the same impeccable credentials. The eggs hatch in spring as they would in the river, and in about a month they're 1-inch long fry. These are what will go back into the wild, to the specific river their parents came from. We're on the Machias River for spring fry stocking. This river also gets very low or 0 adult returns.
Run her all the way through, Dan.
River-specific breeding and fry stocking have been in operation in 6 main rivers since the mid-1990s, with over 1 million fry a year distributed.
Why don't we swing close to these little rocks over here, and I'll put out a few.
It's no exaggeration to say that whether or not wild Atlantic salmon have a future in the United States depends on the river-specific program. If it doesn't work, there's very little chance that the species can recover on its own. The fry hang out in the river for 2 years until they're ready to go to sea as smolts. Then they catch a ride on the spring runoff, like the Pacific salmon, and head out to Greenland to feed and grow. 2 years later, the survivors should be back in the same river to mate, and the cycle begins again. We're back on the Machias River in the fall of 2000. 5 years since the river-specific program geared up on this river. It's the first year we could see a boost in the number of returning adults.
Do you know how many there were here last year or the year before?
The year before, I counted 10 or 11 in here.
We're looking for salmon nests, or redds, in the gravel.
There's no reds. It's kind of surprising. This is a really nice spot here. You have the ideal, or the classic type spawning gravel here. That's why it looks kind of fresh.
One here.
There's a red.
The patch of disturbed gravel is easy to spot. Each female typically builds 2 redds during the fall spawning season, so it's not hard to estimate adult numbers by counting redds. The disturbance in the gravel is where the female flapped her tail to create a pile of stones to cover the eggs just downstream.
0, 5, 8, 9, 7, 5,
They note the
9,
GPS
4,
coordinates
9,
of the
9.
redd so they can come back to check how it does. The Machias had 23 redds in the year 2000, representing 24 adult fish. Not bad, but not a clear improvement. Numbers are unchanged or still declining in the other main rivers, so we don't yet know if the river-specific program is going to work. Wild salmon are in trouble everywhere, but there's no shortage of salmon. In the last 20 years, salmon farming has become a major industry with more than 600,000 tons of fish produced a year. 80% is raised in Norway and Scotland, while Maine has a small industry. Small is relative, though. There's 100 tons of Maine farmed salmon to each individual wild Maine fish. Everywhere, salmon cages are usually very close to salmon rivers. Biologists say the cages that give us cheap salmon are nothing but trouble for the wild fish. One problem is disease. In Norway, for example, they found that young wild salmon can pick up a lethal dose of parasites as they pass near farm cages on their way to the ocean. Salmon farmers check and treat their fish, but you can never be perfect. Another problem is escaped fish. Fish escape everywhere. Here in Norway, an astonishing 1 million fish a year get out. Many run up the rivers and compete with wild fish for food and spawning sites. But Norwegian research shows the offspring are much less successful than their wild neighbors. On this river, scientists have developed an experimental system to remotely detect escaped farmed salmon. It's based simply on how the fish look.
What we have built here is a monitoring unit with a transparent channel that the salmon has to swim through. And we're using 5 mirrors and a video camera to create an image with both a side view and a top view of the fish.
The video pictures are monitored 100 yards from the fish ladder. A returning adult is about to get its picture taken.
Där kommer den.
The system takes a frame of the top and side views of the fish, then makes a simple outline.
Så jag tror vi tar bilder där. Ja, fint bilder. Där har vi.
The basic idea is that wild fish, like this one, are literally in better shape. They're slimmer, and their fins are sharper and less worn.
If you look at the left image of the wild salmon, you can see that the fins are very nice. The dorsal fin is more pointed than the farmed one, which shows signs of wear on the fins.
It's the same with the tail. Wild fish on the left, farmed on the right. Farmed fish get bitten and knocked around in the crowded cages. They also don't get much exercise, so they're fatter. The system's software makes a series of measurements on each fish's profile, then compares the results to typical values. It's right more than 98% of the time. On this river, one of the healthiest in the world, only about 2% of its 5,000 returning adults are farm escapees. It has no nearby farms, but other Norwegian rivers get up to 90% farmed fish. The danger is that interbreeding will steadily dilute the special local adaptations of native salmon until there are no fish left that know how to use a particular river. That is a real risk here in Maine. There have already been large farm escapes, and at some point, the tiny remaining number of wild fish could simply get swamped. The challenge for scientists is to fully understand why Maine's salmon are still declining. That applies equally to many rivers in Canada, Scotland, and Norway, which until recently were regarded as healthy. If the challenge is not met, then the future of wild Atlantic salmon is not bright. How long have you been coming out here with the fishing boats?
I started on tuna in 1993.
It's early on a summer morning, and I'm going fishing with Molly Lutcavage, a marine biologist. We're licensed to catch giant bluefin tuna, but we're also licensed to attach satellite trackers to them. And there aren't many charter boats that can say that. Fishermen have been leaving this harbor for over 300 years, but it's only in the last 30 that anyone's gone after giant bluefin.
How do you know when you're near a place where you're liable to catch a fish?
Sometimes you see the fish jumping or see them on the surface. Sometimes just a lot of banging of birds, maybe.
We're heading out to the giant bluefin's summer feeding grounds. In the 1970s, a gold rush developed for bluefin, which are in demand for sushi. They can weigh up to 1,500 pounds, so a single fish may be worth thousands of dollars. The record is $173,000 for a fish caught near Japan. 50 miles out, we begin to see dolphins and whales. It means we're in the right area.
We often actually track tuna that are following whales. They sometimes accompany fin whales or humpback whales. So most fishermen are very pleased to see the fins of the whales because it's a sign that the tuna may be there as well.
Bluefin are ocean travelers. We know they feed here in summer and spawn in the Gulf of Mexico in spring. Across the Atlantic, we know they feed off the coast of Africa and spawn in the Mediterranean. We're on the Italian island of Sardinia. This is the village of Carloforte. Everyone's shown up for a celebration of spring. The 500-pound giant bluefin showed up to spawn, but the fishermen's nets were waiting, as they have been every spring for maybe 2,000 years. The traditional matanza, it simply means the killing, is celebrated in many Italian fishing villages. Many Mediterranean countries have traditionally fished for tuna, but with the coming of industrial-scale fishing in the 1960s, traditional gave way to modern. Catches shot up and quotas were imposed on both sides of the Atlantic. Back in the Gulf of Maine, we've had a strike on one of our lines. The quotas were based less on bluefin biology than on how many had been caught in the past. Now, biologists like Molly are trying to build up a scientific understanding of bluefin. High-tech tags like this one are one of the key tools. Are bluefins putting up quite a fight?
It's about 150 pounds, so it's a small one.
Our 150-pound fish is 4 years old and half the legal size for sale. It won't spawn until it's reached 8 years. The official estimate is that there are up to 20,000 tuna over spawning age in the western Atlantic. The tag has to be anchored into the strong tendons around the dorsal fin.
Wait for the shot. Nice one.
The tag was placed perfectly, but then it was decided the fish was likely to be in poor shape after the long struggle. So the catch was brought in to end up on the table. One non-commercial keeper per trip is permitted. Over the last 5 years, the boat has tagged about 50 fish for Molly. The tags are designed to record where the fish go, then at a preset date automatically release from the fish, float to the surface, and upload their data to a satellite. They're called pop-up tags. Pop-ups have revolutionized research on ocean travelers like bluefin. We no longer have to make guesses about their habits based on where they happen to get caught. But you still have to catch a fish before you can tag it. And for that, scientists like Molly depend on fishermen. These guys don't have to take Molly out for free or stay out after they've reached their 2 fish a day bag limit. They see the value of good information. They know in the long run, it's the only thing that will preserve bluefin and jobs. Soon after we caught our fish, we almost literally ran into another boat that Molly works closely with.
Yo! Hey! We got it! We got one!
Actually, they were just dropping off some fresh bread. This is a commercial tuna boat that uses nets. They're interested in good science, too.
Thanks for the bread. Good luck! See you guys! It's a vital part of our research program is the Fishermen Partnership. And not just recreational fishermen, but you can clearly see that the commercial fishermen here have been the backbone of our studies for years. And they've really given us our primary fishing and tagging platforms. They've done it, for the most part, on a strictly voluntary basis, and they brought all their expertise to the table, and we didn't have those skills, and we couldn't have done this work without their input.
Molly first began working with tuna fishermen in 1993. They were convinced, based on what their spotter planes saw, that there were more fish out here than the official estimates. Of course, fishermen always make claims like that, but here was a chance to really check out their story. Molly and her colleagues decided to simply count the tuna, using aerial photographs and a mapping system that they set the spotter pilots up with. Every summer for 5 years, the pilots handed in their pictures, and Molly's team laboriously counted every fish they could see. The result surprised even the fishermen. There were huge numbers. On one single day, 17,000 fish were counted just in the Gulf of Maine, about the same as the official estimate for the entire Western Atlantic at the time. But could they have counted the same fish in different places? And also, how many fish might have been out of sight below the surface? So next, they marked fish with acoustic tags and followed them. The aim was to measure tuna swimming speeds to eliminate double counting, and also to assess typical diving behavior.
We found out that they travel anywhere from 24 miles to, say, 30 miles in a single day, and that they spent less than 10% of their time in a single day at the surface where we could see them.
They spend less than 10% of their time at the surface. So does that mean on the day that you photographed 17,000 fish
right.
in one part of the Atlantic, that might have only, the chances are pretty good that was only 10% of the fish in that area?
Well, we don't exactly know what percentage,
or do they all go down
right.
at the same time?
You're absolutely right. It showed us that represents only a small portion of the population that's going to be in the area, because we know that we're only seeing a tiny slice of the water column at the surface.
We're out on the commercial tuna boat we saw earlier. Molly's team now estimates that there are up to 65,000 giant bluefin just in the Gulf of Maine. The research headed off a move to get the Western Atlantic quota cut in half. She was popular with fishermen, but environmentalists said she was irresponsible. The Western Atlantic quota is about 10,000 large fish a year, which it's believed is sustainable. This boat's quota is 50 tons, about 200 large fish. The fishermen are happy to help Molly with her pop-up tag research, even though letting some fish go means it takes longer to fill their quota. In the last 5 years, this boat has tagged nearly 100 fish, more than half the tags put out by all of Molly's collaborating boats. The last few fish in the net find they're not going to end up as sushi. It's probably fair to say that Western Atlantic bluefin fishing is under control. It's well regulated, and catches are reasonable. Things are different on the other side of the ocean. We're back in Sardinia, where Italian scientists are preparing to take advantage of the Matanza to tag some bluefins with pop-ups. The bluefin quota in the Mediterranean and Eastern Atlantic is enormous and probably unsustainable, 20 times the West's. That's because of history and politics, not science. For years, catch quotas were based on the assumption that eastern and western bluefin are separate stocks. But scientists from both sides are now telling regulators they have to think again. So far on this side, they've got results from 23 pop-ups. Here are all the results to date. Molly's, the Italian groups, and also those from a Stanford University group that tagged fish off North Carolina. The clear evidence of the pop-ups is that tuna go all over the place, sometimes right across the ocean and across the theoretical dividing line that's used to separate eastern fish from western.
Has this radically changed what we know about tuna?
It's absolutely radically overturned what was thought about what bluefin did.
Oh, so in what way? To what extent?
Well, and I suppose the biggest point is that the fish are mixing at a much higher rate than was ever believed. So we immediately learned that these fish are not following the rules that everyone laid out for them.
Yeah, right.
And that there's no line down the middle of the ocean and that they hit and they turn around.
Yeah.
So that was an eye-opener to, I think, fisheries biologists and managers, because they realized that what happens on one side of the ocean affects what happens to the fish and the population on the other side.
So it could be that large catches in the east are being fed by good conservation in the west. If that's so, there'll be political problems down the road. The pop-up results offered another eye-opener. Many fish ended up in the spring in the wrong place.
Giant fish that we assume were going to spawn after they got nice and fat and ready to go, they should have been in the known spawning areas during the spawning period, and that would be the Gulf of Mexico or the Med. And for the first 3 years in a row, none of the giant bluefin that we tagged here were in either known spawning area during the presumed spawning period.
So that suggests that there's some area you haven't identified yet.
It raised the question, is it possible that bluefin are spawning elsewhere?
Or do they just take a break?
Or do they take a break?
Yeah, right. It's amazing how much there is to learn about these. And you've been studying them carefully for years.
Absolutely. I think that our independent tagging studies have only raised more questions about what bluefin do for a living.
You can be sure that Molly and her fellow scientists are going to be raising questions about bluefin and about salmon for a while. Regulators are going to be uncomfortable with the process. and fishermen may or may not welcome the results. But the bluefin and the salmon could at least come out of it with a future. Come visit us at PBS Online. Scientific American Frontiers can be found on the World Wide Web at pbs.org or America Online, keyword PBS. This may or may not be real acupuncture, and this may or may not be a real drug. Now here's a provocative question. Does it matter? I'm Alan Alda. Join me next time as Scientific American Frontiers investigates the power of the placebo in the Wonder Pill.
This program was made possible by contributions to your PBS station from viewers like you. Thank you.